Hello and welcome to our second topic for the midterm. So this is the magnetic declination. Okay, so last meeting sa direction of lines pinag-usapan natin yung true meridian and the magnetic meridian, no? And diniscuss natin that the true and the magnetic meridian are not parallel to each other. Okay, so the angle of inclination yung angle na na-create between those two meridians, ang tawag doon ay magnetic declination. Okay, so yun yung ifo-focus natin today. So this will be a very short topic. So hopefully uh, aralin nyo pa din, no? Kahit very short topic lang siya. And madali lang itong topic na ito. And so magnetic declination by definition is the horizontal angle observed from the geodetic meridian to the magnetic meridian. Okay, so another term for magnetic declination is the variation or the deviation of the compass. Okay, so kasi class, di ba, yung compass, sabi nga natin, di ba, compass gives the direction because of the no, or using the magnetic fields, di ba? So yung needle nun, ano yan, kumbaga, na-i-influensyahan kasi siya nung ating magnetic field. Okay, so ang nangyayari ngayon, tinuturo ng ating compass yung papunta sa magnetic north or magnetic south. Okay, hindi talaga North Pole and South Pole ang in a way, syempre, okay, North Pole, South Pole din siya. Pero ang pupuntahan mo nun, kung susundan mo yun, ay magnetic north and the magnetic south, no? Hindi yung actual North Pole and South Pole. Okay, although malapit lang yun sa isa't isa, pero hindi pa rin siya eksaktong parehas. Okay? Yan. So, yung angle na tawag dito, yung angle na difference between the actual, okay, the true and the magnetic, ang tawag doon ay magnetic declination, okay, or variation or deviation. Deviation meaning, yung parang parang hindi tama, parang ganun, or parang error sa compass. In a way, parang ganun siya, parang error. Okay, deviation. Deviation means diba? To deviate means to yung lumayo, diba? Lumayo sa tamang direction, parang ganun. Parang sa values natin sa kumbaga kung sa tawag dito, kung sa most probable value, yung discrepancy. Okay, deviation ang tawag doon. Okay, so because the magnetic pole positions are constantly changing, magnetic declinations also undergo continual changes. Okay, so ibig sabihin, nagbabago, no, every year, yung magnetic declination, gumagalaw. Okay, so there are different variations sa pag-uusapan natin dito, no? We have the secular, daily, annual, and the irregular. Okay? Yeah, so for the secular variation, ito yung tinatawag natin na slow, gradual, pero hindi natin alam kung bakit ganun, no? Okay, unexplainable shift in the position of the Earth's magnetic meridian over a regular cycle. Okay, so ang nangyayari ngayon, yung magnetic north, kung ano man yung position niya ngayon, after 150 years, ano yan, no? Nagmo-move yan. Okay, or hindi every 150 years, no? Kumbaga, every 150 years niya nagagawa yung cycle niya. Okay, for periods of approximately 150 years, there is a gradual, unexplained shift in the Earth's magnetic fields in one direction, after which a gradual shift occurs in the other direction to complete the cycle in another 150 years. Okay, so kunyari, kung titingnan mo sa top view, kunyari lang kung nagmo-move siya ngayon pa clockwise ng 150 years, after 150 years, magmo-move siya pa counterclockwise. Okay, binubuo niya yung cycle. Parang ganyan, basta nagmo-move siya. Okay, so bakit ganun? So hindi natin alam kung bakit ganun, pero ganun talaga eh. No? Kumbaga, nangyayari siya. This is a phenomenon. We don't know what causes this, pero nangyayari siya. And because alam natin na nag-occur siya, we have to consider this secular variation. So this can be very large. Kaya kapag ang ginagawa natin, kunyari, we have survey data that is gathered, kunyari, 100 years ago, hindi na siya kumbaga, hindi siya reliable na yun talaga yung gagamitin. No? Kunyari, especially if hindi naman siya kinorek. Okay, so, if ang ginamit doon is compass, then ibig sabihin that is with respect to the magnetic north of that time, hindi na siya applicable ngayon kasi 100 years ago, medyo malaki na yung variation noon, no? So, we have to do some corrections. Okay? Hindi naman necessarily useless na yung data na yun. No? Pwede pa rin, pero you have to do corrections. No? You have to do computations para maitama mo yung data dati. No? So, para mai-apply mo siya ngayon sa mga surveys ngayon. Kasi kung ginamit mo yung dati, okay, so merong may discrepancy yun, obviously. Okay, so yan, secular variation. Hindi natin alam kung bakit, and 150 years ang niya na cycle niya. No? Hindi natin alam, pero malaki yung effect niya. Okay, so we have to correct this, or we have to consider this if we are considering data that are several years ago na kinuha. 50 years, 100 years, okay. Secular variation. So the daily variation naman is called the diurnal, no? So this is the oscillation of the compass needle through a cycle from its mean position over a 24-hour period. Okay, so class, ang daily variation nangyayari to araw-araw. Okay, so pero alam mo lang na nangyayari. Pero ano yan, no? Sabi nga dito, the magnitude is still so small in comparison to the inaccuracies with which the magnetic compass can be read. Okay, sobrang liit lang nito. So this is 1/10 of a uh, degree. Okay, commonly, yun lang, no? Kumbaga, kapag, kung ano natin yan, no? Kung sa Tagalog ba, yung umaga at saka gabi, kahit parehas mo siyang ginawa, perfect. Okay, meron kang mapapansin na difference. Okay, parehas yung procedure mo, no? May makikita kang difference. Okay, so that is because of the reference niya mismo. Okay, yung magnetic line natin, nagmo-move siya. So, yung compass mo, nagmo-move din. Okay, so, tawag dito, the effect is around, or the error is around 1/10 of 1 degree. Okay, so 1/10 of 1 degree, that is 6 minutes, no? 6 minutes. Okay, so ganun lang. Okay, so maliit lang ito, sobrang liit lang niya kumpara doon sa sa mga ibang pwede mong makubit na error, no? And so, kaya ang ginagawa dito is madalas nine-neglect na natin yung daily variation, no? Nine-neglect na natin yung kadalasan. Yan, so 30 is the annual. Ito naman yung nangyayari every year, no? Bukod pa ito sa secular, ito annual. Kumbaga, in a period of a year, ayan, nagkakaroon din ng mga periodic swing, no? Nagmo-move, no? Yung error, basta may error na nangyayari. Okay, so the value of this is around 1 minute. Okay, so 1 minute. It can be neglected. Sobrang liit lang yan. Okay? And last but not the least is the irregular variation. So this is the unpredictable magnetic disturbances. Okay, so commonly ang nagkukos nito is mga storms or nabasa ko rin na that one thing that can cause irregular variation is yung mga big solid objects, no, like the mountains, no, kapag ka ka sa mga mountainous areas, yung doon yung magnetic field medyo na di-disturb, no? Bakit? Kasi 'di ba alam mo dun sa physics, 'di ba? Sabi kapag ka mas malaki yung mass ng object, nagkakaroon ng attraction, 'di ba? Yung gravity. Hindi lang Earth ang may gravity class, lahat ng bagay in a sense meron. Pero sobrang liit lang compared sa gravity ng Earth. Kaya anong nangyari class? Wag na nga. Pero anyway, yung sa physics class yung yung sa G M1 M2 over R squared, yung kay nalimutan ko. Itong formula na ito, kay Newton ata ito. Kaya ang sinasabi niyan, lahat ng mga bagay na mayroong mass, nag-a-attract sa isa't isa. Okay, and the greater the mass, the greater the attraction. Okay, nangyayari yan dun sa mga, sa mga objects na medyo malalaki and solid, katulad nga ng bundok. Okay, so ang nangyayari niyan, kasi kapag ka nandun sa mga mountainous areas, yung magnetic field doon, in a sense, or in a certain degree, to a certain degree, naapektuhan yan because of the presence of the mountain. Kasi big solid object yun, no? Malaki yung mass nun, and mayroon siyang pull na nagagawa. So, naapektuhan niya yung magnetic field at that point. Okay, so, ayan. Di ba, minsan yung mga helicopter, na di-disturb yung nila, yung radar nila. Ewan, basta ganun. Okay, anyway, trivia lang, no? So, lang, random thoughts. Okay, so anyway, irregular variation can be caused by storm. Kapag bumabagyo, nagkakaroon ng ng variation na di-disturb yung magnetic field. And another yun nga, yung mga presence of big large objects, no? And so that causes variation. Pero yung mga ganyang considerations, hindi na natin pag-uusapan in this course, no? So yan, medyo advanced na yan. Okay, so ayan, doon lang tayo sa mga basic, no? More on secular lang tayo. And class sample problem para mas maintindihan natin yung magnetic declination, no? And so assume the magnetic bearing of a property line was recorded as south 43 degrees 30 minutes in 1862. So this is 100 years plus ago. Okay, so we have to correct this, di ba? Yan. So at that time, the magnetic declination at the survey location is 3 degrees 15 minutes west, meaning yung true north, ito yung yung magnetic north ay 3 degrees 15 minutes west of the true north. Okay, ito, ang sinasabi nito is the declination of the north, ha? Ganun binabasa ang magnetic declination. Okay, so makikita mo dito, nasa west side siya. Okay? That is the effect of the magnetic declination. Now, ang tanong, what is the geodetic bearing needed for a subdivision property plan? Kasi kailangan mo nung yung permanent na direction. Yung with respect to the North Pole, yun yung kailangan mo. Okay, ang tanong, ano yung ilalagay mong data if with respect to the true north siya? Kasi kung kung yun yung i-record mo, baka magkaroon ng problema dyan, di ba? Kasi yan ay with respect to the magnetic north eh. Okay? And ang magnetic north, naggumagalaw-galaw yan. Okay, so yung dating ganyang data, hindi na applicable ngayon yun. Okay, so ang goal natin is, ano dapat yung data na ilalagay mo para doon sa plan permanently with respect to the geodetic bearing. Okay, geodetic bearing meaning true. Okay, with respect to the true meridian. Okay, what is the true bearing? Okay, the permanent bearing. Okay, so kasi permanent, di naman gumagalaw yung north and south pole natin, di ba? Yung true north and true south. Okay, so ganito mangyari, class. At that time, okay, so ito yung magnetic meridian. At that time, class, yung angle from the magnetic meridian is 43 degrees 30 minutes. Ito yung angle. Now, sabi, yung magnetic declination is 3 degrees 15 minutes, and that is equal to this angle. Diba? Sabi dun sa, sa tawag dito. Trigo, diba? This angle is equal to this angle. Okay, so the value of this angle ay equal to 3 degrees 15 minutes din. Now, what is the bearing if with respect to the true? Okay? Meaning, ano daw yung bearing kapag i-measure mo siya from the true meridian. What is the true meridian, class? This is the true meridian. What is the angle? Okay, so what we have to do is to, based on the figure, okay, add. Diba? Sabi sa inyo, huwag kayong maggagawa ng pattern kasi the more you try to find patterns dito, the more na magkakaroon kayo ng problema, no? The answer to your question or to this problem is always to draw the figure, no? Draw the figure, then analyze, then decide kung anong gagawin mo. Kasi sobrang dali lang nito, di ba? Plus minus lang naman. Okay, plus minus lang naman. So, anong kailangan natin gawin, di ba? Draw mo lang. Draw mo lang para hindi ka magkamali. So, this is 43 degrees 30 minutes plus, di ba? From the figure, you will add this small angle. Okay, so this is 3 degrees. Okay, that is 3 degrees 15 minutes. Okay, so you will have your bearing. Okay, so this is the geodetic bearing, and that is south. Okay, south 46 degrees 45 minutes east. That is the final answer. Okay, so sobrang dali lang, di ba? Sobrang dali lang, provided that tama yung ginawa mo, di ba? Kasi ang dito, ang bilis ng solution, ang bilis din magkamali, di ba? Kapag hindi mo siya din drawing. Okay, so please draw the figure. So this is the solution. Okay, so that is the final answer. Sample problem 2. So we have here magnetic declination pa rin. So assume the magnetic bearing of a line AB in 1878 was north 26 degrees 15 minutes east. The declination at that time and place was 7 degrees 15 minutes. Okay, so in 2000, okay, so the declination, ito na, no? Ito, by the way, no, west of 7 degrees 15 minutes west. Okay, ngayon, ang declination na is ito. Ngayon, ang tanong, ano dapat yung magnetic bearing? Ano yung magnetic bearing kung 2000 yan? Okay, ano na yung nare-read mo ngayon? Kasi dati, ito yung na-read. So, ngayon, ano dapat yung reading? Kung ito yung true, nung unang panahon, class, ito yung magnetic. Okay, sorry, baliktad pala. Anticlimactic. Tama. Sorry. Mali nakakita ko. And west nga, west. Ayan. So, this is 7 degrees 15 minutes west. Okay, so this is the magnetic meridian noong 1878. Now, class, ngayon, ang tawag dito, ang ating magnetic bearing na ay 4 degrees 30 minutes Okay? Determine the magnetic bearing in 2000. Class, sabi natin, di ba, kapag gumagamit ka ng compass, yung mga readings mo with respect to the magnetic meridian. Okay, so ganito gagawin natin, class. North, 26 degrees east. Okay, so if we will analyze this meridian, okay, so this is the magnetic meridian noong unang panahon, ha. This is, ito yung itsura niya. Or, sorry. Yan, so, OA kasi yung drawing, eh. Ulitin ko lang, no? I-redraw ko lang kasi medyo mahirap siyang i-analyze. I-redraw natin. Liitan natin, no? Medyo gawin natin mas realistic. Okay, so this is the old. This is the new. Okay, class. This one is 7 degrees 15 minutes. This one is 4 degrees 30 minutes. Now, class, from the blue line, dyan ka nag-measure syempre kasi with respect to the magnetic meridian yung unang ano mo di ba? Yung unang given sa'yo. Okay, so this is north, east. Okay, so medyo around dito yan na. Yan. Hindi lang to scale syempre kasi mahirap i-draw na maliit masyado. Okay, so the angle of this one is 26 degrees 15 minutes. Okay, now ang kailangan mong gawin is to get the bearing of this line with respect to the new meridian. New magnetic meridian. Ito yung hinahanap natin. What is this angle? Okay, so if you will try to analyze the figure, okay, makikita mo that the 26 degrees 15 minutes ay equal to 7 degrees 15 minutes plus the 4 degrees 30 minutes plus the unknown bearing. So, ito yung hinahanap natin. Bearing na bago. Try to compute. Okay, substitute to the value. So, bearing ay equal to 26 degrees 15 minutes minus 7 degrees 15 minutes minus 4 degrees 30 minutes. Okay, so the bearing is 14 degrees 30 minutes. And referring to the figure, makikita mo that the line is along the northeast quadrant pa din. No? Okay, so that is the final answer. Okay, so north 14 degrees 30 minutes east. So that is the final answer. And so if you have questions, please ask, no? So tanong mo lang para maklarify natin. Okay, so sayang kasi kung magkamali ka dito, no? So madali lang kasi siya kung na-drawing mo ng tama. Okay, so yun lang. Pero yun nga, kung may ibang clarifications, no, do not hesitate to ask. And so this is the solution, no? So ni-write lang natin para mas maayos. Okay, so that's it, no? That's it for this topic. Okay, ano lang siguro, tip siguro, class, maraming declinations dito, no? So na pwedeng mag-occur. Okay, pwedeng dalawa ang mag-occur, no? Pwedeng may local attraction because of solid objects, mga ganun nga, no? Local attractions because of storms. Kaya ang mangyari lang nun, basta i-add mo lang yung mga effect, no? Ganun lang din mangyayari sa kanya. Okay, so makita nyo na lang sa ano nyo, sa quiz nyo. So basta mag-add yung mga effect. And basta i-drawing nyo, tapos ano, yun na. Drawing nyo lang, tapos decide kayo, plus ba or minus ba. Yan, ganun na siya. Madali lang siya. Okay, if you have clarifications or other questions, do not hesitate to ask. If wala naman, then that's it for this topic. Okay, so ayan, see you next meeting or lecture.